So this is lesson 7.2, division property of exponents. This is your DLD lesson for February 3rd. We're going to use the principles for reducing fractions. So the first thing I want you to think about is 2 to the 6th power divided by 2 to the 3rd power. Well, 2 to the 6th power can be expanded to look like this. 2 times 2 times 2 times 2 times 2 times 2. 2 to the 3rd power can be expanded to look like this. 2 times 2 times 2. We know that we can reduce just like with fractions. I can take a 2 out of the numerator and the denominator. A 2 out of the numerator and the denominator. A 2 out of the numerator and the denominator. So all I have left in the denominator is the number 1. And in the numerator I have 2 times 2 times 2, which is 8. And 8 over 1 is the same thing as 8. So we have a rule or a property, it's called the quotient of powers. To divide powers with the same base, the rule is that we subtract the exponents. So I'm going to go back up to this 2 to the 6th divided by 2 to the 3rd and think of it using this rule. 2 to the 6th, they have the same base. 2's 6 minus 3 is the same thing as 2 to the 3rd, which equals 8. All right, my first example, y to the 9th divided by y to the 3rd. Remember the rule, if the base is the same, I can subtract the exponents. Y to the 9 minus 3 power equals y to the 6th. For example 2, I want to focus on the constants. 8 divided by 2, which equals 4. And then I want to focus on my powers. I have x to the 5th over x squared. That's the same thing as saying x to the 5 minus 2 power, which is x cubed. So example number 2 actually simplifies to equal 4x cubed. All right, we have another property. It's called the power of a quotient. To find the power of a quotient, we have to find the power of, that shouldn't say off, that should say of. We have to find the power of the numerator and the power of the denominator. So let's take a look at that. So 2/3 raised to the power of 3. Well, that's the same thing as saying 2/3 times 2/3 times 2/3. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. But that's the same thing as 2 to the 3rd power over 3 to the 3rd power. So it doesn't matter how you think about it. Either way, whether you expand the exponent as repeated multiplication or you use the quotient property, you're essentially distributing that 3 to the numerator and the denominator. You're distributing the exponent throughout the fraction. So let's look at example 4. I have 4h cubed divided by 6h, all raised to the 2nd power. I have to take that 2nd power and distribute it to the 4. I have to distribute it to the h cubed. I have to distribute it to the 6, and I have to distribute it to the h. Now, let's see. I'm going to rewrite this as 4 squared. And I learned yesterday that if I have a power raised to a power, I essentially just multiply the exponents. 3 times 2 is 6. 4 squared over h to the 6th power. 4 squared times h to the 6th power over 2, let's see, I'm going to distribute that 2nd power to the 6. That becomes 6 squared h squared. Okay. Now let's take care of our constants. 4 squared is 16. 6 squared is 36. When I divide by 4, I can reduce that to 4 over 9. Using the quotient rule, if the bases are the same, I can subtract the exponents. H to the 6 minus 2 equals h to the 4th. So I can write it as 4/9 times h to the 4th, or I can leave it as the fraction 4 over h to the 4th, all 4 times h to the 4th all over 9. These both have the same value. These are the same thing. Okay? You see this sneaking in here? What about 3 to the 5th divided by 3 to the 5th? Well, when you first learned about fractions, you realized that if you have the same thing in the numerator as the denominator, that equals 1. Well, let's use the property, the quotient property, and see what that says. If the base is the same, and I'm doing a division problem, I just subtract the exponents. Well, 5 minus 5 is 0. So this becomes 3 to the 0 power, but it also equals 1. So we can conclude that any non-zero number, 3 is not 0, raised to the 0 power is, yes, you guessed it, 1. So anything raised to the 0 power is the same thing as the number 1. All right, what about 4 to the 3rd divided by 4 to the 5th? Well, using the quotient of powers, that's the same thing as saying 4, the base is the same, to the 3 minus 5 power. But that equals 4 to the negative 2 power. So let's talk about negative exponents. Let's see. I know 4 squared, let's do some thinking. 4 squared is 16. 4 to the 1st power is just 4. We just learned that anything to the 0 power is 1. What am I doing each time? As I go down, I'm dividing by 4. Right? 16 to 4 is the same thing as divide by 4. 4 divided by 4 equals 1. So what do you think 4 to the negative 1 power is? Well, 1, if I follow the same pattern, divided by 4 is 1/4, and 4 to the negative 2 power, well, 1/4 divided by 4, dividing by 4 is the same thing as multiplying by a 4th, equals 1 over 16, which is the same thing as 1 over 4 squared. So it looks like when we have a negative exponent, we get rid of or eliminate that negative by writing the constant as a reciprocal. So let's see. 4 to the negative 2 power, well, that's the same thing as the reciprocal of 4 is 1 over 4, and that gets rid of my negative, so that's 1 over 4 squared, which equals 1 over 16. If the negative is in the denominator, you move it to the numerator. If the negative is in the numerator, in order to make it positive, you move it to the denominator. So let me show you another example. 1 over 2 to the negative 2 power. Well, the only way to make this positive is, what is the reciprocal of 1/2? The reciprocal of 1/2 is 2, and then the exponent becomes positive. 2 squared, which is the same thing as 4. So let's look at this example right here. 2/5 raised to the negative 2 power. Well, the first thing I have to do is I have to reciprocate that. The reciprocal of 2/5 is 5/2, and then I can square it. Now we learned that we have to distribute that power, so that's the same thing as 5 squared over 2 squared, which equals 25 over 4. All right. Example number 6, I'm going to erase all of this just so I have plenty of room. Example number 6 is a little bit intense. So the first thing you see is I have a power of a quotient, but I have a power raised to a power. So yesterday's lesson, a power raised to a power that has to get distributed. So let's write that first. So I'm going to get rid of this, or distribute. Okay, so this becomes 5 squared. And then let's see, I distribute this by multiplying the exponents. Negative 2 times 2 is r to the negative 4. S to the negative 4 times 2 is s to the negative 8. T to the 3 times 2 is t to the 6th. All over 20 squared. R to the 5 times 2 is 10. S to the negative 3 times 2 is negative 6. Negative 2 times 2 is t to the negative 4. Okay, so let's deal with our constants first. 5 squared is 25. 20 squared is 400, and that reduces nicely to 1 over 16. So keep that there for a second. Let's see. Now I know that if from the quotient of powers, if the base is the same, that's the same thing as subtracting. So I have r to the negative 4 minus 10, which equals r to the negative 14th, which I'm going to write as 1 over r to the positive 14. Another way to think about that is the only way to make this happy or to get rid of the negative is to move it down. 10 plus 4 is 14. The only way to get rid of this negative or to make it happy is to move it down. So now I have a negative 6 plus 8, which makes that 1 over s squared. This is positive. The t to the 6th power is positive, but I need to make this happy, and the only way to do that is to move it up plus 4. So I end up with 1 over 16 times t to the 6 plus 4 is 10, r to the 14th s squared. And I can actually get rid of the 1 since I have the t there. So number 6 right here, that's what it looks like simplified. So that becomes, whoops. So this is lesson 7.2. Here's your homework, page 402. You have 14 questions. You're going to have to take it one step at a time. This lesson is actually a blend of lesson 7.1, so you have to remember all of your multiplication properties as well as the division properties, as well as anything raised to the 0 power. Remember that that equals 1. And then you have to think about negative exponents. 4 to the negative 3 is the same thing as 1 over 4 to the positive 3, which equals 1 over 64. So if you have a negative exponent, the only way to get rid of the negative exponent is to change the position. You have to rewrite the whole number as a reciprocal. If it already is a fraction, again, like 1/5 raised to the power of negative 2, well, the only way to fix that negative 2 exponent is to rewrite it as a reciprocal, 5 over 1 squared. Well, 5 over 1 is the same thing as 5, and the number 5 squared equals 25. Okay? Good luck.